All right, let's see what we can do. That's one way to do it. Hmm. Well, we can try it. Hmm. Yeah, I got the same issue. My extrude thread goes in, but I have to look up the, which we can do. We can look up the standard. Let's see here. So for quarter 20 thread, the minor diameter is 188 and 7/10. Mm. 195. Doesn't seem right. All right, let's look and see what the tapped hole cut for its geometry. I bet it removed. This is a quarter. Yeah, so this is the, not the hole that we want. So we want to do a hole like this, probably. How deep did it call out? 650. Should be a tap, right? Not a die. That was total depth. I wonder if I can make this negative. Nope. All right, so that's probably what the issue was, is that he was using a tap or a die instead of a tap. Not sure what created this sketch. Might have been me, I guess. All right, now let's make sure it's right. So the inside diameter. All right, so the inside diameter is actually the diameter of a of the drill that you would use for the tap, which is 210, which is double the radius of this part right here. So in steel, for 75% thread engagement, you would use a 210 drill before you tapped it. Now let's see if the major diameter is correct. Yeah, so, that's why I created that. I created it to use it as measurement, which is why it broke when. Mm-hmm. 255. Yeah, I'm not sure where it's pulling its dimensions from. Probably the thread standard. I'd have to look it up though. I have a tap and clearance drill chart which gives some dimensions for the thread, but I wish you could get this to come all the way through without doing another feature. But it is what I'm bet. I guess it's better than nothing. So if you have to draw another feature to get this to come all the way through, maybe just do the whole thread in that feature. I don't know, guess kind of depends. All right, so now I'll just tell them that we found the answer. Yeah, he probably has it set on inch tap or inch die, which is what it defaulted to. Okay, let's see if we can duplicate the problem. So he made a circle, and he makes a line, bisecting it, and then he trims it, and then he tries to extrude. Okay. I'm gonna guess that his circle, the line that he made, is probably not correct. He probably did something like this, which just off ever so slightly. And then he trimmed, maybe. And then, I guess you can still select the profile. Let's see here. Because then it would allow you to do a thin feature, right? Unless he didn't trim the ends. Maybe one end's not connected. Like that. But it still lets you, I guess if you turn off thin feature. All right, we send him a message. Let's see what he says. don't really have a practice. You might be able to go into the tutorials though. I'm sure they're doing those in class already though. Where's it? Help? Maybe in here. Yeah, tutorials. So this is a good place to find some help sometimes, or like there's actually some really good, even more advanced stuff when you're doing like CSWP accreditation preparation or simulation tutorials. There's some really good simulation tutorials in here as well. Sketch blocks, sure. 3D sketching, multi-body parts, mold design. Yeah, there's even like pipe and tube, electrical, circuit works. I think there's, yeah, API stuff in here as well. Create the intersection curve, but have not been able to remove the parts using the 3D sketch formed. Help me out, please. Interesting. This might be interesting to do. So there's a couple different ways to make a weldment, for one. And then as far as mitering the tubes together, So we can just add it directly, just Weldments tab. If you don't see it, try right clicking, go to tabs and just turn it on in here. There's also a bunch of other interesting things that you can find in here. So we can just do Weldment, right? And that's going to add the Weldment feature. And then you just do structural member, and that'll allow you to select sketches. And you can see this is automatically mitering the pipes where they come together. It has a bunch of different options for different profiles. It's really just using that original base sketch and then applying the profile to it. These look huge because our sketch was originally scaled down for the when we were doing the circle or the half circle issue. So you can change the way that it applies the corner treatment. So these are all just different options. I think this is probably what he wants. But let's assume that you didn't have this, right? Like, let's assume you didn't have automatic mitering on. And the cool part is just with everything else in SolidWorks that if we change this, like so we change the angle on it, it'll automatically update. So now we can see that that miter is still correct. And so that's just creating the sketches and then extruding them along the lengths of our original sketch, the wireframe. So let's say now that you wanted to do this a different way without doing weldments. So we can do the same way or a similar way, right? We'll just make it some off angle here. Doesn't really matter. We'll go to feature. We won't use the weldments tool this time, so you can do sweep. We can do a circle, and that's going to collect all of them. Let's see if there's a way we can turn off propagation. So we'll just make a second sketch, and we can drive it from in here. So now we'll do the same thing, sweep, round, sure, 10 millimeters. If we wanted to make them hollow, this is not necessarily the way I'm saying to create these, just for effect and for demonstration purposes. Just showing different tools, different ways to do things. See, now that'll be an issue here because these won't miter correctly. It sounds like he did his within a also we don't want them to merge. Sounds like he did his within an assembly, so he might have two predefined parts that are coming together, and he needs to merge, or he needs to edit them. Okay. So we can modify this sketch. Or what would be the proper way to get the correct length? It's probably to go in and edit this here, right? So we have something like this and something like this. And we know that these are what I think we did 10 millimeters. So I'm just adding the extensions now of these lines so that when we change, so that the parts we're creating will go all the way to the end. Maybe make this a little bit more robust. Probably shouldn't have tied it to the origin. Well, that's okay. These are all construction lines because they won't be used outside of the sketch. And then you can see as we change the angle in here, at that point, those lengths are going to update. So now when we go and we'll import these extensions and it'll propagate down. And again, this is just making something that so we can show how they miter. So we have the parts coming out far enough for now to the correct length, or actually beyond the correct length, so that we can successfully miter them. We could figure out what the angle is between them. That's one way we could do it. So we can go back into the sketch again. And this is going to be, so this is 135, right? Let's say we want to do it geometrically, not based off of a dimension. We can make this line here symmetric about these two, which are constrained, right? Now we can make a plane. Let's do it this way. Plane right in here. Yeah. So we'll make a plane using that as a reference. Going through here. And now one way you could do it is just using cut. We can cut with surface. We can split the bodies. Could do all bodies. No, actually, we don't want to do this. Yeah, I think we'll do a split because a cut will actually cut it'll delete everything on one side of this plane. All bodies, we'll keep all of them. Cut the bodies. Actually, yeah, we will cut all the bodies. And then we can just go through and delete them. Hide the sketch. Hide this. And now we have a mitered joint using the plane. So what's another way we could do it? All right, so we'll suppress these. We're back to our tubes again. We could do a combine. We could copy the bodies out and use a combine. That could work. Use a split line. You could use two cut with surfaces. Just cut one way on one body and one way on the other. Yeah, I mean, I think that original way is probably the cleanest. And we can cheat, unsuppress this, and then do a cut with surface. Using that plane again. And we just do two of those, which I guess is just as clean as now it's wanting to add this, like this surface here. Is that being added before or after I do the it's before, so it's in the way that the surface that the sweeps are being created. Yeah. There we go. That cleans it up. So we're just checking merge tangent faces. Because it's actually creating it as two segments. The way that we did our sketch, we have like the main part, and then we have this extension so that we can miter. And if when it does that, it creates as this main surface as two surfaces, like the first section and then the second section. And if you turn on merge tangent faces, because they're tangent, it'll just create it all as one surface. But the fixes still work. It just looks a lot cleaner now. So let's say this is a part and make an assembly out of it. What's another way to do this? So we're just going to go in and change the angle so that we have two distinct parts that we can merge together. You can see that we changed the angle. So it doesn't want to go over 90, and that's the way that I built the sketch with the extensions. Which might be one advantage of doing this within Weldment, where it's going to do it all pretty much automatically. But it doesn't seem like, or it didn't sound like his original design was done as a Weldment, so this is just showing different techniques. But yeah, the way that we built the sketch to define the extensions, it doesn't want to go past 90 or up to 90 because our extension lines will cross over, and that'll cause issues. I wonder if, yeah, I think it's these little lines here. because it won't, when it tries to go through 0, they go to singularity, and the sketch doesn't like that. I wonder if you can just jump it though. Yep, so you can jump it. You just can't do exactly 90. Yeah, let's leave it at 45. Not 0 though. It needs more extension here, obviously. So now we'll go in and we'll make this a different angle just for this configuration. All right, so we've got our different parts. It's actually the same part, different configuration. So now we'll somehow butt these together. We're going to constrain them using the sketch, because that's more, it's more lightweight. Something like this. So we're just going to create a point, offset some distance, and then we can put the sketch through that point, right? Obviously, when you do this, you'd have something that's constraining these already. This is just to create a situation where we have to do a miter cut between them, like a worst possible scenario. All right, so he's saying that he has an intersection curve that he's trying to use to cut the parts, which is one way to do it, I suppose. You could make a surface with the intersection curve, possibly. That might be cool. So we'll edit the part. All right, where were we? So he was creating intersection curves. Hmm. I'm not quite sure how he's making them though. Like I'm trying to think of how you would make an intersection curve in this situation. You're copying in the surface, maybe? I copy the other one because we're within we're within this part already. Offset. Well, let us do that. Yeah. I mean, you could just cut it with the surface, right? I mean, you copy in the part, you could make this a solid, use combine to cut it out. I don't think it's gonna like cut the surface though. Yeah, looks like it does it. Huh, there you go. That works. So you just offset the surface in, it creates a external reference indicated by this arrow. And then you use, what was that? Cut with surface. And then select which side that you want to keep. Now, how you do it for this side, probably the same thing. I might create a circular reference though, where they're both not going to be able to cut each other because the the miter's not going to be correct. the miter's not going to be correct because when we go to offset this surface, even though we could use it to cut it, the miter angle or the side will not be correct. Yeah, I'll show you. It might be easier to just try it and show. So we'll do the same thing. We're going to offset the surface, this surface. And the issue is not that this is not through, right? Like we can hide this body if we want to. See that the surface does not go through our part, which isn't the end of the world because we can use extend to maybe we can't use extend. Maybe it doesn't like that. It's probably not going to cut anything. Yeah. Okay. Trying to think of how he may have done it where he's using an intersection curve. So this works on one part, like on one side. Something funky there. But it won't work on both because apparently you can't extend the surfaces. I mean, you could obviously like trim the surface back, make it flush, extend it, but that's really kind of convoluted for what we're trying to do, I think. I mean, if I had two parts, I think I'd do the same way that we did when we, or yeah, if we have two parts, I think I'd do it the same way that we did it when there was an assembly. Right? Like maybe show the parts, we'll roll this one back. Right, we'll show their sketches again. Two planes, maybe? Actually, we use that point that we used before. And then you do the same thing. We're doing cut with surface again. With that plane. Won't let us make it. So maybe you have to make it twice. Or I wonder if we can make a reference plane within the part file that, yeah, just coincide with the plane. That worked. Now we just cut with plane or cut with surface. That'll work. So we make a reference plane that is identical to the one that we've described or that we designed within the assembly. And you could just create it locally originally, I guess. But then that allows us to use cut with plane or cut with surface. That's probably quite robust too, because it's just planes based on sketch geometry. Like if we move this, what is this? That's the offset surface that we were going to use. Yeah, like now we can drag this around and it'll continually update. Wherever we want it to go. Rebuild it. Miters. Which is kind of cool. Yeah, I think if you didn't want to do a mutually mitered connection like this, and you just wanted to do like a butt style of miter, I think copying the surface in and using cut surface seemed to work well. But in that case, part of me says, if you're going to do that, you might as well use the sketch geometry from the part that you're going to use to cut away. And just extrude cut based on the diameter, maybe. That might be better. Less calculation intensive, possibly. Instead of using a surface and copying it in and then using a cut. Might be a better way to go. All right, I'm out for the day. Hope you have a good night, and I will see you guys tomorrow. Feel free to stop by and ask any questions.